In this video, we will see how to evaluate this complex quantity, that is 40 at an angle of 50 degrees plus 20 at an angle of minus 30 degrees, and sum of these two we have to take, then square root of that one. Okay, and in order to solve this one, we have to follow some rules. Those rules are, for example, if you have the complex number z is equal to x plus jy, and another complex number you have z2, that is equal to a plus jb. These two can be added conveniently. That means z1 plus z2 if you want, or z1 minus z2 also you can do. First I am showing z1 plus z2. Real parts can be added. That means x plus a can be added. Here x is real, y is imaginary. Here a is real and b is imaginary. So two real parts are added plus j. If you take common in the imaginary parts, you will get y plus b. This is the way of adding two complex numbers when those are represented in the rectangular form. Here z1 was given in the rectangular form and z2 is also given in the rectangular form. Then we can able to perform the addition like this, or subtraction also similar to this one only. But whenever if you want to perform the division operation, you need to go for, our multiplication operation, you need to go for polar form. That means the same z1 we can represent in the polar form like r1 at an angle of theta 1. It is a polar representation. And how to get r1? R1 is equal to root of x square plus y square, and theta 1 is equal to tan inverse of y by x. This is the way of writing polar from the rectangle. Okay, now similarly z2 also I am writing in the polar form like r2 at an angle of theta 2, and to write r2 I need to take a square root of a square plus b square, and to write theta 2 and to use the formula tan inverse of imaginary part b by real part a. Now in this case, now you have observed that I have taken the conversion from rectangular to polar. Similarly, we can able to have conversion of polar to rectangle also. That means when you have z1 is equal to r1 at an angle of theta 1, then z1 in the rectangular form is given by r1 cos of theta 1. Okay, it is just a real part plus j, and imaginary part is given by r1 sin of theta 1. That means it is actually x plus jy. So x is equal to, you can write r1 cosine of theta 1, and y is equal to r1 sin of theta 1. Like this you can able to convert from rectangle to polar and polar to rectangle. Okay, and the interesting thing is, when you have division of z1 and z2, then you need to write z1 z2 in polar. That means r1 at an angle of theta 1 by r2 at an angle of theta 2. Then, because r1 and r2 are real numbers, you can divide these two conveniently, but theta 1, theta 2 should not be divided. Theta 1, theta 2 are to be subtracted. Now, the resultant polar representation of this one is this one. Okay, and then you may get some doubt. Why do we require the subtraction of these two angles? Means this is actually shortcut representation of the polar. Actual polar representation or the exponential representation is r1 e power j theta 1 by r2 e power j theta 2. Now you will be having more clarity, because r1 and r2 are real numbers, we can divide these two directly, but by sending this denominator e power j theta 2 to the numerator, e power j into theta 1 minus theta 2, like this we can write. Now in shortcut we can write now r1 by r2 at an angle of theta 1 minus theta 2. Okay, so what is required to be remember means, when it is required to have the division, write those complex numbers in the polar form. Not only in the division, in the multiplication also. For example, z1 z2 is there, then r1 at an angle of theta 1, it is to be multiplied with r2 at an angle of theta 2. It is equal to r1 r2 and these angles are to be added. You know the reason, because e power j theta 1 into e power j theta 2, e power j times of theta 1 plus theta 2, so that you can able to write like this. Okay, so addition or subtraction go for rectangular form. Okay, division or multiplication, it is simply r, then go for polar form. Okay, now we'll see the question what they have given. The question is 40 at an angle of 50 degrees plus 20 at an angle of minus 30 degrees, square root of 1 by 2. This is what we have to evaluate. Okay, because this part was given in polar, this part was also given in polar, but which type of operation is there in between them? Here addition is there. So addition can be done when the complex numbers are in rectangular form. So it is required to convert this 40 at an angle of 50 and 20 at an angle of minus 30 into the rectangular form. We know how to convert them. That is 40 cos of 50. It is the real part, 50 degrees, plus j 40 sine 50. It is the imaginary part. So 40 at an angle of 50 has been converted into the rectangular form using this one. Plus now 20 at an angle of minus 30 also I am going to write. That is 20 cos of minus 30 plus j 20 sine of minus 30. Like this I can write. Now it is the rectangular representation of 20 at an angle of minus 30. Okay, so whole power actually what is there? 1 by 2 is there. Now the real you can able to calculate the value of this 40 cos of 50. Okay, so you may get this one like this, 25.71 using calc you can able to perform that one, plus j 30.64. Okay, then and the second one is you will get 17.32 minus j10 power 1 by 2 is there. Now in place of this entire thing you got this, and in place of this one you have written this. Now you see 25.71 and 17.32 can be added conveniently, so that you will get that is 47.72. Then it is 30 minus 10, that means plus j 20.64. Now power 1 by 2 is there. To apply this square root, again this inner part should be in the polar form only. How to write in the polar form? It is in the rectangular form. Now we have to write in the polar form. That can be done by using square root of 47.72 square plus 20.64 square. Okay, and this magnitude you will get 47.72. Sorry, this is not 47.72, it is 43.03. Okay, so you will get the magnitude 47.72, and you can able to calculate angle. Angle can be calculated by tan inverse of 20.64 by 43.03, and angle you will get 25.63. So this entire thing you can write like 47.72 at an angle of 25.63. But what is there? Power 1 by 2 is there. So 47.72 at an angle of 25.63 power 1 by 2. Here one more interesting thing is, it is now in the form of r at an angle of theta, but power 1 by 2 is there. As I said, r is the real number, r power 1 by 2 you can calculate, but what about this theta means? Theta power 1 by 2 we cannot write. What can we write in the sense? It is theta by 2. Okay, theta power 1 by 2, actually we have square root, but actually what is happening means theta by 2. How it is possible means we can write this r at an angle of theta as r into e power j theta. Now you apply 1 by 2. It is equal to r power 1 by 2 e power j theta by 2. Okay, now you write again in the shortcut form, that is r power 1 by 2 at an angle of theta by 2. This is what we need to do. So what is the final answer now? Square root of 47.72 at an angle of 25.63 by 2. This is what we need to perform. Okay. So in this way you can able to done the calculation. So finally what will you get now? It is equal to, you can get 66.91 at an angle of 12.81. Okay, these are in degrees. Thank you.